in Unit 2, the fundamental forces in the nature. Before we start our lesson, we must determine what they mean by the force. Let's do an activity. I'm going to ask you, this ball under the table, does it move? Of course not, because there is no one acting the force on it, right? So the ball doesn't move. The second one, this ball, it will be moved, right? Why? Because this player kicked the ball, so he affects the force on the ball. So the ball moves by the force which acted on it. The third one, this tennis ball, this player can change its direction because he affected the force by this ball. So we can conclude that force pi, it is an effect that attempt to change the object state. Like this one. This is a chair. This is a chair. When I'm going to move it forward and backward, forward and backward. So this chair moves by my force. Like this man, he tried to move the block by his force, forward or backward. So he first going to change the state of the object. If it's static, to motion. Static means it doesn't move. I'm a static motion, and there I'm in a static state. Here I'm going to move. So this is a motion state. Again, this is static and this is motion. So when I'm acting the force on the object, I'm going to change its state from static to motion. Or I can change its direction from left or right. So again, the force, its definition, it is an effect that attempts to change the object state from static to motion or may change its direction. And of course, we have known that the measuring unit of any force will be measured by Newton. Again, the measuring unit by Newton. Let's continue. We have two pictures. The two boys, they are going to make a force. But the first one, we are going to see the block will be moved. So we are going to call this force a proper force. Again, repeat after me. A proper force. Proper force. What do I mean by the proper force? It means the force acted on the object and the object moved. And the second point, he acting the force on the wall. He tried to push the ball, but the wall will not move. Why? Because the force acted on the wall is called improper force. Improper force. So we have two types of the forces. Proper force, improper force. Proper force means the object affected by the force and it will be moved. And improper force, the force acted on the object and the object doesn't move. Let's continue. Now we are going to discuss the different types of the forces present in the nature. If you have 1 minute to think about the forces present in the nature, which happen in the nature, and you can feel it, okay? Like what? Like the lightning. From the few days ago, you saw the lightning and you hearing the thunder, right? And also we saw the wind motion. This wind motion, we saw it very clearly. Also the attraction force of the object. If you remember, you have holding this pen. What happens if I left it? It will be falls down. Why? Due to the attraction force of the earth toward its center or toward its surface. And these forces can be used in generating electric current. You know that the wind motion, we can use the wind in making electricity. Also, we can use it in making the fire weapons or atomic reactors or nuclear reactors. Let's continue. Now we are going to divide the forces into 3 forces. We are discussing in this lesson. First, we're going to start with the attraction force, and then electromagnetic forces. Third one, the nuclear force. And the nuclear force has 2 types, weak nuclear force and strong nuclear force. Let's start with the first one, the attraction force. The attraction force, of course, is discovered by Isaac Newton. He is a great scientist who discovered that the attraction force by falling the apple on his head. And so, the attraction force was discovered by Newton. And this gravitational force is called by the object weight from primary 6. If you remember, the object weight. What do I mean by the object weight? It is the gravitational force of the earth to attract the object to its center. So, again, what is the object weight? Ability or the attraction force of the earth to what? To attract any object. this pen is attracted to the earth. If I'm lifting it, it will be falls down. Any object. Our body is attracted to the earth's surface due to the gravitational force of the earth. And of course, it will be measured by Newton. Here I'm remembering to you the rule to get the weight. How can you calculate the weight? From this magic triangle, the mass in kilogram, of course, times the gravitational force. Weight equal mass by the gravitational force. And you must understand the mass must be in kilogram. What happens if he gives to you the mass by the gram? You will convert it into kilogram. Let's make it. Mass in gram. So you will divide it over 1,000 to convert it into kilogram. Understood this part? Let's continue. The factors affecting on the object's weight. We have two factors affecting on the object's weight. We have the object's mass and the gravity acceleration. Let's start with the object's mass. Here in the picture, we have two poles. The first pole is a metallic pole which is made of metal. And here we have the rubber pole. The rubber pole is a very light pole. Okay? The two persons try to lift the two poles together. We saw the first man, he has a great effort, a great force to lift this pole because it has a high mass. Why? The second boy, he easily can lift the pole. Why? Because it has a less mass. So we have the conclusion quickly. If the mass of the object increases, the gravitational force of the earth will be increased. And if the mass decreases, the gravitational force will be decreases. Understood this part? So this is a direct relationship between the object's mass and the gravitational force of the earth. Let's continue. And here we said, the mass of the object is constant, it doesn't change. If your mass on the earth is 60 kilograms, it will be the same on the moon or the Jupiter or any place on the ground. So the mass is constant, but the weight is variable. Again, the mass is constant, it doesn't change, it has a fixed value, while the weight has a variable constant. So the object will be changing its weight according to the place of the object. What happened here? If you are in the North Pole, your weight will be changing. Why? Because the distance between the equator to the North Pole is different from the person here. Let's see the second picture. Here we have the persons in the four places. The person here at the North Pole, like the person here at the equator, like the person here in the North Pole? Of course not. Why? Because the distance from the center of the earth to the object differs from this distance. Why? Because as we saw, the earth has a non-spherical shape. The earth is a non-regular circle. The earth is a not regular circle shape. It has non-spherical shape. And this is the reason why the weight of the object differs from one place to another. The last one is the object center of the gravity. The object center of the gravity, it means it is the point where the center of the object is affected by the gravitational force. Here we have this point. This pole is affected by this center of the gravitational force, where the object will be stand accurately, like this one. Here the boy tried to equilibrate the gravitational force of this bird, so he will hold it from the center to can be held very well. So easily the object center of the gravity, it is the point of the center of the object at which the force will be affected. Here we are going to stop in this point. We finished the attraction force of the earth. Now we are going to study it very well and we'll come back soon. Thank you. Goodbye.